Hi, I'm Jonathan Stevens, and in this video, I'm going to show you how to take your old Nerfstudio projects and convert the data to be able to use in 3D Gaussian splatting so you don't have to rerun COLMAP again. Now, one caveat here, if you're watching this and you don't use COLMAP to get your images ready for Nerfstudio training, then this actually won't work for you. I just want to make sure you see that distinction, because what we're able to do is use the COLMAP data that we used in Nerfstudio and reuse it for 3D Gaussian splatting, and that will speed up things a little bit. You still got to go through the training, but let's jump into it. All right, what I have on my screen here is all of my some of my old Nerfstudio projects, and I'm just going to take this top one for example, and let's see if I can make this feel a little bigger. What you'll see is a folder called COLMAP, and that's got some like COLMAP files in there. You'll have an images 2, 4, 8, most likely. And those are basically your images that COLMAP used. And then half scale, quarter, and eighth scale resolution. And then I have my source images. Those were before I threw them through COLMAP. The video I took these from, and this transforms.json file. And that's what I'm going to move into my 3D Gaussian workspace so I don't actually mess up my old Nerfstudio data. So the first thing I do is I'm just going to copy this. Then here's my Gaussian splatting folder. I'm just going to paste it in there. That way I don't mess up anything. And if you watched my video on how to get started, which I recommend watching, I'll link it in this, you'll see that I always make a just Gaussian splatting project has a data folder where I keep all my projects. You can do whatever you want. This is how I do it. So now I'm in here. I have this Butler folder, and they tell us right in here how in the GitHub repo documentation, how we're supposed to basically set up this folder structure with our old files to run the conversion and not have to run COLMAP. And it's just right here. And this just might look different to what you're used to looking at. So if I go back here, the first thing, if I have these side by side, I'm going to make these big for you guys. The first thing you'll see is that it says, okay, we have my location, and then we need an input folder with your images. So I'm just going to take this images folder and call it input. Like so. Super easy. While I'm at it, I'm going to delete these subsampled ones because it doesn't say to have those. So I just took them out. You might be able to reuse those. I haven't confirmed. And then you have this distorted folder with your database.db, sparse 0, and all that. And if you open up your COLMAP, you'll notice that's what you're looking at. So we just need to rename COLMAP to distorted. Super easy. And then since I don't really care to keep all this other information, I'm just going to delete these two, this transforms file and the video. Oh, and I don't need the sources. Delete all that. So you just ended up with these two folders. Then I need to run this Python conversion. So if I go to here, let me just start a new Anaconda prompt just so you see the full thing. First thing I need to do is change directory to Gaussian splatting. And then I'm going to activate my Anaconda environment just so I don't forget. Gaussian splatting. Again, this is my getting started tutorial. Make sure you watch that if you haven't watched it. And then from here, I'm just going to paste that Python execution here. So what we have here is, it says Python. So it's calling Python, the program, telling it to run a Python script called convert. And then the location, this S is the source location. So I'm going to just put in data/Butler. That's what mine's called. So whatever your folder is in and subfolder, that's what it needs to be. So if I go back to this, you'll see that, not this one. Just going to delete that out. If I just go to this, you'll see I was in my Jonathan folder, which is C user Jonathan, and then Gaussian splatting, and then data and Butler. So that's where we get the data Butler. And then skip matching. So what we're saying is skip COLMAP matching, which is great. And then if we want to resize to different sizes, leave that in. I'm going to do this just so you can see it. If you're never going to resize your imagery, you're just going to use the source imagery or just have it do the auto resize like it will. You could just leave that alone. So just hit enter, and then it'll basically undistort all your images for you. That doesn't take long. It took me like a fraction of a minute. And now it's going to copy and resize. So you'll start to see all these folders populate in the background resizing. And this might take a minute or two. Okay, it's done. If you go to the folder, you'll see it says this run colmap geometric.sh, the photometric.sh. Those should be in there. A stereo folder has been added, a sparse folder. So now you got everything you need. So all we got to do is go back to this. It's already have my environment activated, everything. I just needed to go to type in Python train.py source data butler. So again, we're going to run instead of convert, we're going to run train. We're going to run it on the same location that we just prepared all the images. Hit enter, and it takes a second, but it'll read all the images in and start the training. And now it says it resized all these images. So I'm just curious what my images are. They're not very big, but I think it's going to resize them all to 16K. Again, you could have told it not to, but just know you run into a memory cap. If you have a lot of images, 279 like 4K, you'll run into a cap. Okay, so here it is. So now it's training. So that was great. I'm just going to let this run, and I will be able to look at my results in the end. Okay, it looks like it completed successfully. That's good. It took me 16 minutes, 45 seconds. That's really quick. So now again, reminder, anytime you run it, it creates an output model. And I'm going to rename this to the same thing as my input, so I don't have to think about that. I'm just going to launch the viewer to see my data. So I'm just going to, again, change directory to viewers/bin. So, and then I can just type in SIBR tab -m. Again, this was in my tutorial video. And let's just go to where that model is. And I'm going to copy and paste this path in. Enter. And it will launch my viewer. And there we go. There's our scene. Pretty cool. You can move around it, everything. And I didn't have to use COLMAP. This scene actually probably wouldn't have taken too long on COLMAP on this PC, but some of your large scenes that maybe ran for an hour, now you don't have to do that again. So that should speed things up for you. Hope you found this helpful. And again, put in the comments if you have any questions about what I did. If I went over anything too quick, and I will modify my version of the fork to GitHub so you can see a little bit more instructional how I did that, so you can watch the video, but also maybe have a little bit clearer text instructions as well. So I will see you guys in the next video, as I have lots of tips and tricks around 3D Gaussian splatting. So make sure you follow me if you want to see more of this.